Hello there, and welcome. I'm glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who finds comfort in letting the quiet vastness of the universe carry you towards sleep. Either way, you don't need to do anything now except rest. Settle into your breathing, let your shoulders drop, and allow your mind to wander gently, as if it were drifting on a calm tide. Tonight, we're not rushing anywhere. We're letting ourselves be carried slowly, softly, into one of the most beautiful mysteries of the cosmos, the nebula. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or pressed the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now, let's begin. A nebula is often described as a cloud, but it is far more than vapor hanging in the dark. It is the breath of dying stars, the cradle of new ones, and a gallery of colors painted by the simplest elements in the universe. To the eye, it can look like smoke or a whisper of fog stretched across the night sky. To the telescope, it reveals structures hundreds of light years wide, glowing with the faint radiance of atoms stirred into light. To the imagination, it is almost everything at once: a graveyard, a nursery, a lantern, and a veil. When astronomers first looked through their telescopes centuries ago, many galaxies were mistaken for nebulae. To them, these distant spirals looked like faint, cloudy patches. The word nebula itself simply means cloud in Latin, and yet the name stayed with the things we now know are truly clouds of gas and dust. They are places where the universe hides and reveals itself, sometimes blocking the stars behind them, other times blazing so brightly that they light up entire constellations. They are as changeable as smoke in the air, but on scales that unfold over millions of years. The Orion Nebula, visible even to the naked eye under dark skies, is one of the closest stellar nurseries to Earth. Through binoculars, it looks like a faint smear beneath Orion's belt. Through larger telescopes, it blossoms into wings of gas, threaded with newborn stars. Within it, clouds of hydrogen collapse into dense knots, gravity pulling them tighter until they ignite into new suns. Every star that has ever existed, including our own sun, once formed in such a place. And long after stars have burned their fuel, they exhale their outer layers back into space, creating planetary nebulae, expanding shells of light that glow like halos. Even in death, a star becomes a cloud. Some nebulae are dark, blocking the starlight behind them like a hand over a candle flame. These dark nebulae, such as the Horsehead in Orion, look like silhouettes cut out of the stars. Inside them, however, stars may be forming quietly, hidden from view until they shine strongly enough to burn through the dust. Others are reflection nebulae, clouds that do not glow themselves but shine with borrowed light, like mirrors catching starlight and scattering it into blue haze. Still others are supernova remnants, the scattered remains of stars that exploded violently, flinging their matter into space and stirring the chemistry that seeds planets and life. Nebulae are not just pretty forms, they are engines of creation. Inside them, hydrogen atoms collide and fuse, giving rise to helium, carbon, oxygen, and all the elements we breathe and carry in our own bodies. Dust within nebulae is not inert. It holds complex molecules, including the same carbon-based structures that form the building blocks of biology. When we say that we are made of star stuff, what we mean is that we are made of nebulae. We are the cooled, gathered, and living consequence of these clouds drifting and glowing in silence. As you imagine drifting among them, picture the way their colors shift depending on the gas within. Hydrogen glows deep red, oxygen shines green, dust reflects the blue of starlight. These colors, enhanced in telescope images, are not just decorations. They are signatures of the elements themselves. Each nebula is like a lantern filled with different flames, each flame telling us what it is made of and how it burns. If you let your mind wander, you can almost see them as lanterns floating on a great river, each one carrying a piece of the universe's story across the night. Nebulae are vast, but they also remind us of fragility. They are shaped by winds from stars, sculpted into arches, fingers, and curtains. The pillars of creation in the Eagle Nebula are columns of gas light years tall, eroded by radiation but still cradling new stars. To us, they look eternal, but in truth, they are temporary. Cosmic smoke caught mid-shape. In another few million years, they will be gone, their gas consumed or blown away, leaving behind only the stars they birthed. As we move through this series together, we'll explore 100 quiet truths about these clouds, the science, the history, the mysteries, and the wonder. Some of what you'll hear will surprise you. Some may sound almost like poetry disguised as physics. And that's fitting, because nebulae are both science and story. They are where the laws of physics become art. They are where the cold machinery of matter becomes the luminous beauty of a night sky. Think of each chapter as a lantern. One by one, we will light them, and together they will guide us through a constellation of knowledge. Some facts will tell us about immense distances, others about tiny particles drifting in silence. Some will take us to famous nebulae we already know, others to obscure corners of the sky where clouds faintly glow, waiting for the right instruments to reveal them. By the time we have gathered all 100, you will not only know more about nebulae, you will feel their presence as part of your own story. And for tonight, as you breathe a little slower and let your eyelids soften, let this first light be enough. Nebulae are not just clouds in space. They are the universe reminding itself that nothing is wasted. Stars die, but their breath becomes the seeds of new suns. Dust drifts, but within it are the molecules of life. Light travels, and in that light are stories written across billions of years. You are drifting in the same current, carried in the same orbit, and part of the same endless cycle. So rest now, as the nebulae do. They are patient, unhurried, and eternal in their motion. Let them carry your thoughts out of the day and into the night. Somewhere in the distance, clouds of gas are glowing quietly, stars are stirring, and dust is waiting to gather into worlds. The story continues whether you are awake or asleep. Tonight, you are simply drifting in its glow. If you've ever looked up at the night sky and felt that quiet pull of mystery, that sense that behind the darkness there is something more waiting to be discovered, then you've already touched the idea of a nebula without realizing it. The word itself comes from Latin, nebula, meaning simply cloud. That's all it was at first, a way to describe the faint, hazy patches early astronomers noticed when their eyes or their crude telescopes revealed smudges of light that didn't resolve into stars. These were the cloud things, the ghostly stains on the heavens. At the time, no one knew whether they were close or far, small or unimaginably vast. They were just shapes in the dark, reminders that the universe often reveals itself as a whisper long before it speaks in detail. With time, we learned that these clouds were not all the same. Some were indeed true nebulae, colossal structures of gas and dust suspended in the galaxy, their size dwarfing entire star systems. Others, however, turned out to be galaxies themselves, vast islands of stars far beyond our own. Before telescopes improved, there was no way to tell them apart. The Andromeda Galaxy was once thought to be just another nebula, a local patch of glowing mist. Only later did we understand that it was a spiral of hundreds of billions of stars, a universe in miniature, separated from us by millions of light years. This confusion was natural. because both galaxies and nebulae appear as faint smudges to the naked eye. One is a city of stars, the other is a birthplace for them, and yet to human vision, they once looked nearly identical. The nebulae that remained, once the galaxies were sorted out, turned out to be extraordinary in their own right. They are the great stages of stellar life. Within them, stars are born when gravity gathers clouds of hydrogen and squeezes them until fusion ignites. In them, stars also die, casting off their outer layers in glowing shells or exploding with furious brilliance, leaving their remains scattered across space. A nebula can be a womb or a tomb, a nursery or a graveyard. It can be a place where new suns spark into existence, or where the ashes of an ancient star glow faintly before drifting away. They hold beginnings and endings so close together that it becomes difficult to say which is which. A dying star's remains are, after all, only the starting material for the next generation. When you imagine a nebula, picture a cloud that is not static but restless. It is stirred by winds from nearby stars, shaped into filaments, pillars, and veils. Some shine because the radiation of newborn stars energizes their gas, making them glow with soft colors. Others glow only by reflection, scattering the light of stars hidden deep inside them. Some, darker still, obscure the stars behind them entirely, appearing as silhouettes of shadow against the glittering background of the Milky Way. Each type is a reminder that nebulae are not one thing, but many. They are masks, mirrors, lanterns, and veils all at once. The beauty of the word nebula is that its original meaning, just cloud, still fits, even after all we've learned. When we look at a nebula through a telescope, we see light and dust arranged like weather on a planetary scale, currents and storms playing out across light years instead of miles. And yet, while earthly clouds are shaped by winds and water droplets, nebulae are written in atoms and gravity. They move slowly, often imperceptibly, changing form over thousands or millions of years. To us, they seem frozen, but in reality, they are flowing, shifting, sculpted by invisible forces. Astronomers sometimes describe nebulae as signposts of transformation. They appear where something is happening, where matter is being rearranged, recycled, reborn. In the Orion Nebula, we see the restless glow of stars being born, hot and unruly in their infancy. In the Crab Nebula, we see the shreds of a star that exploded 1,000 years ago, its tendrils of gas expanding outward while a tiny neutron star pulses at its center. In planetary nebulae like the Helix or the Ring, we see stars like our Sun casting off their outer layers, a farewell gift of gas and dust to the cosmos before collapsing into white dwarfs. Every nebula tells us change is happening here. This cloud is a hinge between past and future, between what a star was and what new stars will become. And perhaps that is why nebulae have captured the human imagination so strongly. They are both beautiful and unsettling, reminders that creation and destruction are not opposites in the universe, but companions. One star's death seeds the birth of another. Dust released in a glowing veil may someday gather into planets, into oceans, into living creatures. When you look at a nebula, you are looking at the in-between, the liminal space where matter is neither here nor there, neither finished nor undone. It is the cosmos in motion, paused just long enough for us to glimpse it. In this way, nebulae are less like static objects and more like verbs, actions playing out over unfathomable stretches of time. A nebula is forming, a nebula is dispersing, a nebula is collapsing. To study one is to catch the universe mid-breath, exhaling or inhaling, never still. Even the most familiar, like Orion or the Eagle, will one day fade into something else, their clouds scattered or consumed. But for now, in the blink of our human lifetime, they appear fixed and eternal, monuments of gas and dust lit by stars. So when you hear the word nebula, remember that its simple translation, cloud, hides a far deeper meaning. These are not clouds of rain, but clouds of time, filled with the ingredients of suns and the stories of endings. They are reminders that the universe is always in the middle of becoming something new. To look at one is to be reminded of our own place in this endless cycle. We too are clouds in transition, formed from the dust of past stars, destined to dissolve back into the cosmos. As we drift further into this journey together, keep that in mind. Nebulae are not just objects scattered in space. They are the signs that transformation is constant. They are the gentle handwriting of the universe, tracing across the night sky that nothing stays still, not even the stars. The night sky may look like a simple scattering of stars, but hidden among them are shapes and forms that tell us there is far more unfolding than our eyes can easily see. Nebulae come in many varieties, each with their own story to tell, each with their own role in the endless cycle of stellar birth and death. They are not all the same, and the differences between them reveal the richness of the universe's imagination. Just as clouds on Earth can gather as towering thunderheads or thin veils of mist, cosmic clouds take on personalities defined by light, shadow, and motion. Some shine on their own, some glow with borrowed brilliance, and some hide in darkness until the moment is right to reveal what they hold. Among the most luminous of these are emission nebulae. These are clouds of gas that shine because young, hot stars embedded within them release floods of ultraviolet radiation. That energy strips electrons from hydrogen atoms in the surrounding cloud, and when those electrons find their way back, the gas releases light. To us, this light most often appears as a deep crimson glow, the signature of hydrogen. These glowing lanterns can stretch across dozens of light years, bathing whole regions of space in their radiance. The Orion Nebula is the most famous example, its heart filled with newborn stars whose fierce energy makes the surrounding gas blaze. To gaze upon such a nebula is to see light not just reflected, but created anew, a raw testament to how stars sculpt their surroundings. But not all nebulae shine in their own right. Some are quieter, more delicate, content to borrow light rather than make it. These are reflection nebulae, clouds of dust that scatter the starlight from nearby suns. They are often painted in hues of blue because the tiny particles scatter shorter wavelengths more effectively, just as Earth's sky appears blue by day. The Pleiades star cluster is wrapped in a fine veil of this kind, its young stars caught in a haze that looks like silk stretched across the dark. Reflection nebulae remind us that even the faintest dust can hold beauty, and that not all light needs to come from within to be meaningful. Sometimes it is enough to catch what shines nearby and scatter it into the night. There are nebulae, though, that are not luminous at all. These are the dark nebulae, clouds so thick with dust that they block the light of the stars behind them. At first they may look like voids, empty patches in an otherwise starry sky. But their darkness is not absence. It is concealment. Behind their veils, stars are often forming, invisible to optical light, but blazing in infrared wavelengths that pierce the gloom. The Horsehead Nebula is one such shadow, a striking silhouette against the bright curtain of gas behind it. These nebulae are like secrets in the sky, refusing to show their treasures until the time is right. They remind us that creation often begins in silence and shadow, hidden until the moment of revelation. Then there are the planetary nebulae, perhaps the most misleadingly named of them all. They have nothing to do with planets, but when early astronomers peered at them through small telescopes, their round shapes resembled distant worlds. The name stuck, even as understanding deepened. These nebulae are the final acts of stars like our sun, shells of gas shed as the star's outer layers drift away. What remains is a glowing bubble, often symmetrical, sometimes ring-shaped, sometimes more intricate, illuminated by the hot remnant of the star at its center. The Ring Nebula and the Helix Nebula are among the most haunting examples. their delicate halos like cosmic eyes staring back at us. They are ghosts, beautiful and ephemeral, lasting only tens of thousands of years before fading into the larger galaxy. Planetary nebulae are reminders of mortality, of how even the most ordinary star can leave behind something extraordinary in its passing. And finally, there are the most violent nebulae of all, the supernova remnants. These are not quiet exhalations but catastrophic detonations, when a massive star reaches the end of its life and explodes with unimaginable force. The result is chaos. Gas hurled outward at thousands of kilometers per second, tangled filaments stretching across space, shock waves plowing through interstellar material. The Crab Nebula is the relic of such an event, the remains of a star that exploded in the year 1054, bright enough at the time to be seen in daylight. Today, its filaments still race outward, lit by the energy of a pulsar at its core. These nebulae are messengers of destruction, but also of renewal, because they scatter heavy elements, carbon, oxygen, iron, into the cosmos. Without such storms, planets could not form, life could not begin. In their chaos is the seed of future order. Taken together, these many types of nebulae form a spectrum of creation and dissolution, of silence and fury. They are chapters in the grand story of matter itself, moving from one form to another, never ceasing, never lost. To look at them is to see the universe not as something static, but as a living, breathing process. Each nebula, whether glowing red with hydrogen, shining blue with reflected starlight, veiled in darkness, haloed in death, or shredded by explosion, speaks to a moment of transition. They are all signposts, telling us that here, in this cloud, the universe is at work, reshaping itself for the next act. As you drift deeper into this thought, imagine yourself floating among them, passing from one to the next. First through the glowing gas of Orion, then into the blue haze of the Pleiades, then into the black silhouette of a dust cloud where stars stir unseen, then onto the delicate rings of a dying sun, and finally into the ragged storm of a supernova where everything is scattered and yet everything is renewed. Each type is different, yet all are connected, bound by the same cycle of life and death written across the stars. In the end, nebulae teach us that there is no single way the cosmos creates or destroys. There are many forms, many faces of the same truth. Just as clouds on Earth can shift from thunderhead to wisp to fog, nebulae shift in form and meaning, each one carrying a different message, each one holding a different role in the endless unfolding of the universe. And as we rest here, imagining them in the quiet of the night, they remind us that transformation is everywhere, that nothing is ever truly still, and that even in darkness or destruction, beauty continues to bloom. Nebulae are not only clouds drifting through space, they are places of beginnings, cradles where stars are born. In these vast, cold regions of gas and dust, the quiet work of gravity shapes the future. What seems from afar like a haze of light or a patch of darkness is in truth a workshop of creation, where atoms gather, where pressure builds, and where the fires of new suns are kindled. These stellar nurseries are among the most important sites in the universe, for without them, no stars, no planets, and no life could exist. They are wombs in which the next generation of the cosmos is prepared, silent in their scale, patient in their timing, and luminous when viewed with eyes tuned to their glow. The Orion Nebula is the most famous of these nurseries and the closest to Earth, lying about 350 light-years away. Even with the naked eye, it can be seen as a faint smear in the sword of the constellation Orion, but through a telescope, it blossoms into color and depth. Clouds of hydrogen stretch like curtains, lit from within by young stars that have only just awakened. At its core lies the trapezium cluster, a handful of massive newborn stars whose light and wind carve the surrounding gas into sculpted shapes. This one region alone contains thousands of stars in various stages of formation, each a glowing promise of a future sky. The Orion Nebula is not merely a sight to observe. It is a reminder that we live in a galaxy still alive, still producing, still carrying forward the eternal work of making light. The process of starbirth begins quietly, almost invisibly. Within a cold molecular cloud, gravity starts to gather material together. At first, the clumps are diffuse, hardly distinguishable from the rest of the gas around them. But over time, they grow denser, their gravity stronger, pulling in more material, feeding themselves in a long, slow collapse. The gas heats as it falls inward, pressure building until, at the center, the temperature rises to millions of degrees. When that threshold is reached, hydrogen atoms begin to fuse into helium, releasing energy. That first spark of nuclear fusion is the birth cry of a star. What began as darkness and dust becomes a source of light that can shine for billions of years. Yet stars rarely arrive alone. Most are born in clusters, sharing the same parent cloud, their lives beginning in close proximity. For a time, they are siblings, sharing the same gravitational home. In some cases, clusters remain bound, like the beautiful Pleiades, their stars still moving together long after birth. But in most cases, the family is scattered. Over millions of years, the pull of the galaxy, passing stars, and internal dynamics gently break the bonds. The siblings drift apart, scattered across spiral arms, carrying their shared origins in silence. Our own sun was likely born in such a cluster, its siblings now far away, their identities lost among the billions of other stars. Somewhere in the night sky, they still shine, but they are no longer close enough for us to know them as kin. The birth of stars is not a peaceful affair. The very stars that form first begin to shape the environment for those that follow. Massive stars, burning with fierce energy, pour out radiation and stellar winds that carve cavities in the clouds, compressing some regions while dispersing others. Their influence can trigger new rounds of collapse nearby, setting off cascades of star formation, or it can blow material away, halting creation. In this way, stars do not simply emerge from their nurseries. They sculpt them, acting as both midwives and destroyers. The Orion Nebula's dramatic shapes, its pillars and arches, are the direct result of this interplay, evidence that starbirth is not silent, but full of energy and change. When we look at these nurseries, we see not only stars in formation, but the beginning of planetary systems as well. Around many of these young stars, disks of dust and gas swirl, the raw material for future planets. Within these disks, grains collide and stick, slowly building larger bodies until entire worlds emerge. The Orion Nebula contains hundreds of such protoplanetary disks, small silhouettes seen against the glowing gas. Each one could become a solar system, complete with planets, moons, asteroids, and perhaps in some distant epoch, life. In the clouds of Orion and other nurseries like it, the seeds of countless futures are being sown. The scale of these nurseries is difficult to comprehend. They can span hundreds of light years, vast enough to contain thousands of stars. Yet within these immense expanses, the drama plays out in countless small pockets, each collapse a separate story. A single nebula can be both a graveyard and a birthplace, with old stars shedding material at one end, while new ones ignite at the other. The cycle of matter is constant, dust from ancient deaths recycled into new lives, atoms reshaped into fresh stars and planets. To call them nurseries is not just a metaphor. They are truly places where the universe cares for its young. To drift through such a place in imagination is to wander through corridors of possibility. In one corner, a cluster of bright blue giants pours their light across gas clouds. In another, delicate filaments shield the quiet growth of smaller, dimmer stars. Farther on, a disk of dust glows faintly in infrared, a future world being drawn together from particles too fine to see. And everywhere, the gas itself shimmers, not empty but alive with process, alive with the slow turning of gravity into light. Stellar nurseries remind us that the universe is not finished. It is still building, still weaving new stars into its tapestry. Though billions of stars already shine across the galaxy, new ones are always waiting, hidden in the veils of gas, gathering in silence until they are ready to blaze. When we look at Orion on a winter's night, we are looking at one of the most active building sites in the cosmos, a place where the future is being forged, one star at a time. And perhaps the most humbling thought of all is that we ourselves trace our origin back to such a place. Our sun, our planets, and even the atoms of our bodies began in a nebula long ago. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it passed through a nursery of stars. We are, in a very real sense, children of these clouds, born from the same processes that now play out in Orion and beyond. To look at a stellar nursery is not only to see creation in progress, it is to see the reflection of our own beginnings, glowing softly across the night. The story of stars and nebulae is not a straight line, but a circle. Stars are born in the cradles of nebulae, live their long luminous lives, and when their fuel is gone, they return much of what they are back into those same cosmic clouds. Every nebula we see is not just a birthplace, but also a graveyard, filled with the ashes of ancient stars and the ingredients for new ones. The universe has no waste. Nothing is discarded. Everything is recycled, endlessly reshaped into new forms of light and motion. It is a process that has continued for billions of years and will go on for billions more. When a star like our sun reaches the end of its life, it does not explode in violence. Instead, it swells into a red giant, its outer layers expanding far beyond their original reach. For a time, it glows huge and swollen, unstable but brilliant. Then, gently, almost tenderly, it begins to shed its outer atmosphere into space. These drifting shells of gas expand outward, glowing faintly under the light of the dying star's core. Astronomers call these planetary nebula, though they have nothing to do with planets at all. The name is a relic from early telescopes when such objects appeared round like distant worlds. In truth, they are the final size of suns, luminous bubbles that expand and fade over tens of thousands of years. At the center remains a white dwarf, a tiny ember of a star, cooling slowly over eons. Around it, the nebula shines, delicate and colorful, a last breath made visible across light years. For stars much larger than the sun, death is far less gentle. These giants end in fire. When their nuclear fuel runs out, gravity overwhelms them in a catastrophic collapse. The core shrinks in an instant, crushing matter to extremes, while the outer layers are flung outward in a titanic explosion. This is a supernova, one of the most powerful events in the cosmos. For a brief time, a single star can outshine an entire galaxy, releasing more energy in a moment than our sun will emit in its entire lifetime. But the brilliance is not just spectacle. In the heart of the explosion, new elements are forged: iron, gold, uranium, and countless others that cannot form in ordinary stars. The blast scatters these heavy elements into space, seeding the galaxy with the raw materials for planets, oceans, and life itself. Without supernovae, there would be no Earth, no air to breathe, no bodies to carry our thoughts. The clouds that remain after such an explosion are among the most beautiful structures in the sky. The Crab Nebula, for example, is the remnant of a supernova witnessed by Chinese astronomers in the year 1054. What they saw was a new star, suddenly bright in the sky. Today, we see the shredded remains of that explosion, a vast cloud expanding outward, glowing in tendrils of gas and light. At its center lies a pulsar, the collapsed core of the star, spinning rapidly and beaming radiation like a cosmic lighthouse. Around it, the debris stretches in delicate filaments, a silent reminder of both destruction and creation. These remnants are not only graves, they are nurseries in waiting, places where new stars will one day emerge. This cycle of death feeding birth is perhaps the most profound truth nebulae reveal. The Orion Nebula, where new stars are being born right now, contains elements forged in countless ancient explosions. The very hydrogen that fuels its newborn stars is mixed with heavier elements, remnants of those that came before. Every nursery is seeded by its ancestors, carrying forward the chemistry of past lives into the future. In turn, the stars that form there will one day return their own material, continuing the circle. Nebulae are both past and future, holding within them the remains of yesterday and the seeds of tomorrow. Even our own sun will one day join this cycle. Billions of years from now, it will swell into a red giant, shed its layers, and form a planetary nebula of its own. Its gases will drift into space, illuminated for a time by the white dwarf it leaves behind. Eventually, that nebula will fade, its material blending into the interstellar medium, perhaps becoming part of a new star or planet far in the future. The atoms that make up Earth and us will continue to wander, folded into the next generation of the cosmos. Death, in this sense, is never an ending. It is a handoff, a continuation of the story. To imagine this process on a galactic scale is staggering. Every star you see in the night sky is part of this endless rhythm. Billions of stars have already died, their material scattered across the Milky Way. Billions more are forming at this very moment in distant nurseries, glowing faintly in nebulae we can barely glimpse. The galaxy itself is like a forest, where old trees fall and new saplings rise, where decay and growth are not opposites but partners. Nebulae are the soil of the cosmos, enriched by the ashes of stars, fertile with the promise of light. When you look at a planetary nebula or a supernova remnant, you are not only looking at what was lost, you are looking at what is yet to come. The glowing shells of gas drifting into the dark will someday collapse again, drawn together by gravity, igniting fresh stars. Around those stars, disks of dust and gas will form, gathering into planets. On some of those worlds, chemistry may take hold, forming oceans, atmospheres, perhaps even life. A supernova in the past gave us the atoms in our bones. A nebula in the future may cradle the beginnings of another story entirely. The life and death of stars and nebulae is a reminder that the universe is never finished. It is always in transition, always moving from one form to another. Nebulae are the signposts of that transformation, glowing lanterns that mark the turning of the cosmic cycle. They tell us that nothing is wasted, that even endings are beginnings, that we are all part of a rhythm older and greater than ourselves. In the end, we too are nebular matter, drifting through time, waiting to be reshaped into something new. When we look at images of nebulae, it often feels like gazing at a painting made on a canvas far too large for human hands to have touched. Sweeps of red, arcs of green, and delicate wisps of blue seem almost too vivid to be real. And yet these colors are not inventions. They are signals, fingerprints of the atoms and dust drifting in the vastness of space. Nebulae glow, not because someone painted them, but because the universe itself radiates light in ways both subtle and spectacular, telling its story through color. The most common color you will see in nebulae is red, deep and warm, the glow of hydrogen. Hydrogen is the simplest and most abundant element in the cosmos, and when ultraviolet light from newborn stars energizes its atoms, they release light in a very specific shade of crimson. This glow is called the hydrogen alpha emission line, and it is like a signature, unmistakable and universal. The Orion Nebula shines with this red, a diffuse lantern visible even to small telescopes. It is the same red that marks countless other regions where stars are forming, so that across the galaxy, hydrogen writes its presence in ink that never changes. To see that crimson hue is to see the breath of the cosmos itself, for hydrogen is the primal element, the foundation on which all stars and worlds are built. But nebulae are not painted only in red. Oxygen, when excited, produces a green glow that can seem ghostly, almost unearthly in its beauty. This oxygen emission is rare and requires very specific conditions, but when it appears, it gives nebulae their haunting emerald edges. The Ring Nebula, for example, glows with a mix of hydrogen's crimson and oxygen's green, creating a palette that feels alive, as though the cloud is pulsing with light from within. To the eye, this green can appear faint, but with long exposures through telescopes, it blossoms into vivid, shimmering arcs. It is not an artist's brush, but the physics of atoms, the dance of electrons jumping between energy levels that paints those spectral hues. In the silence of space, color is chemistry turned luminous. Then there is blue, which appears not from atoms glowing but from dust scattering starlight. Reflection nebulae, like those around the Pleiades, shine in this soft cobalt haze. The process is similar to why Earth's sky is blue. Shorter wavelengths of light scatter more easily than longer ones. As starlight passes through clouds of fine dust, the blue light is scattered in every direction, giving the nebula its characteristic hue. These reflection nebulae are not producing their own glow. They are mirrors, quietly redirecting the light of nearby stars. Their color is cool, fragile, delicate, compared to the deep warmth of hydrogen red or the eerie glow of oxygen green. They are reminders that sometimes beauty is not in creating light, but in catching it and passing it along. Yet the human eye, marvelous though it is, struggles to see these colors directly. Most nebulae appear grayish or faintly tinted when observed through a telescope without assistance. Our eyes are not sensitive enough to pick up the rich hues at such low light levels. What cameras and telescopes do is gather light over long periods, stacking photons one after another until the image becomes bright enough to reveal the palette that is really there. Filters are then used to separate the different emission lines: hydrogen red, oxygen green, sulfur deep red, and assign them to visible colors. Some images are true color, showing what our eyes might see if they were more sensitive, while others are false color, designed to highlight specific gases. But even false color is not false in spirit. It is a translation, a way of taking light our eyes cannot process and turning it into something we can witness. What this means is that the famous pictures from telescopes like Hubble and James Webb are not exaggerations, but revelations. They show us the truth of nebulae in ways our biology cannot. When we see those great curtains of red, those tendrils of green, those mirrors of blue, we are seeing the language of atoms written across space. We are not being deceived. We are being given access to a level of perception beyond what our bodies can naturally achieve. It is like hearing a frequency too low for human ears or seeing the shape of the wind. The colors are there, whether we notice them or not, etched into the fog of space. The effect of this is more than scientific. It is emotional. To know that each color corresponds to an element is to feel the universe's palette tied to its structure. Red for hydrogen, the fuel of stars. Green for oxygen, the breath of life. Blue for dust, the delicate veil of creation. Each hue carries meaning, each shade a piece of the story of how stars are born and die, how gas is scattered and reformed, how matter endlessly reshapes itself. Even the darkness between them holds weight, for where there is no light, there is dust dense enough to block it, a shadow waiting to burst into color when touched by a new star. Imagine drifting through such a nebula. Around you, faint red arcs glow softly, while a green shimmer flickers near the edges. A veil of blue dust hangs nearby, scattering starlight like smoke caught in a beam of light. It is not silent in color but rich, alive, whispering the physics of atoms in luminous tones. The scene would be faint to the naked eye, but through the right instruments, it becomes a symphony of hues, each one evidence of the unseen processes shaping the galaxy. Colors in the cosmic fog are not random. They are signatures, truths written in light, fingerprints of the elements from which stars and planets and people are formed. To see them is to understand that beauty is not added to the universe as decoration, it is woven into its very physics. Nebulae glow not because they want to impress us, but because the laws of nature demand it, because atoms cannot help but shine when stirred by energy. And in their shining, they give us both knowledge and wonder. So when you see an image of a nebula, alive in crimson, emerald, and cobalt, remember that you are not looking at fantasy. You are looking at the universe expressing itself in the simplest and most profound way it knows, through light. Each color is a message, a trace, a reminder that in the darkness of space, the cosmos is always painting, always writing, always alive with the quiet radiance of creation. Some nebulae are so striking that they become more than astronomical objects. They turn into icons of wonder, symbols of the universe's beauty that transcend science and lodge themselves in the imagination of anyone who has ever seen their images. These are the famous nebulae, the ones whose names carry a kind of reverence, whispered in planetariums, classrooms, and late-night conversations under the stars. They are not just clouds of gas and dust. They are monuments in the sky, each with a story that speaks of creation, destruction, and the profound artistry of nature itself. The Orion Nebula is perhaps the most beloved of them all. It is the closest stellar nursery to Earth, and one of the brightest, easily visible as a faint blur just below Orion's belt. For thousands of years, people looked at this patch of haze without understanding what it was. But today we know it as a vast cloud, stretching dozens of light years across, brimming with newborn stars. At its heart lies the trapezium cluster, 4 young, hot stars whose light and winds sculpt the gas around them into rippling waves and arcs. Through a telescope, Orion seems alive, a place where creation is happening in real time. It is our nearest glimpse of the process that gave birth to our own sun long ago, a reminder that the sky we admire is not just decoration, but a living workshop of stars. Then there is the Eagle Nebula, and within it, one of the most famous astronomical sights ever captured, the Pillars of Creation. These towering columns of gas, each light years tall, stand like cosmic cathedrals, eroded by the fierce radiation of young stars, yet still cradling pockets where new stars are forming. The name is fitting, for the image conveys both the majesty of creation and the inevitability of change. The Hubble Space Telescope's 1,995 photograph of the pillars became an instant icon, appearing on posters, book covers, and even album art. For many, it was the first time the grandeur of the universe felt tangible, captured not as an artist's impression, but as a photograph of what truly exists. The pillars remind us that even in a place where destruction is constant, creation pushes forward, persistent and luminous. The Crab Nebula tells a different story, one not of birth but of death and transformation. In the year 1054, astronomers in China, Japan, and the Middle East recorded a new star in the sky, one so bright it was visible in daylight. What they witnessed was a supernova, the death of a massive star. Almost 1,000 years later, the expanding remains of that explosion are still visible, stretched into delicate filaments of glowing gas. At its center lies a pulsar, a neutron star spinning dozens of times per second, sending out beams of radiation like a cosmic lighthouse. The Crab Nebula is a ghost, the remnant of a life ended in fire, but it is also a monument to renewal, scattering elements like carbon and iron across space. Without such deaths, no new planets or living beings would exist. The Helix Nebula is quieter, but no less moving. It is a planetary nebula, the final breath of a star like our Sunday. From Earth, it looks like a giant eye staring out of the darkness, often called the Eye of God or the Eye of Sauron for its haunting symmetry. At its heart, the dying star's white-hot core illuminates the drifting rings of gas that it shed long ago. The helix is both fragile and immense, stretching across light years while glowing faintly in the sky. To look at it is to glimpse the future of our own sun, billions of years from now, when it too will cast off its outer layers and form a glowing halo before fading into darkness. The Carina Nebula is one of the largest and brightest regions of star formation in our galaxy, far bigger than Orion, and home to some of the most massive stars known. Within it lies Eta Carinae, a star so huge and unstable that it has already survived one titanic eruption, ejecting a vast double-lobed cloud of gas now called the Homunculus Nebula. Carina is a region of extremes, where stars form in dense clusters, where some live brief, violent lives before exploding, and where others may shine for millions of years. The images of Carina, taken by Hubble, and, more recently, the James Webb Space Telescope, reveal structures so intricate that they look sculpted by hand, arcs, ridges, and cavities glowing in every color of the cosmic palette. What these nebulae share is not just their astrophysical importance, but their emotional power. The photographs taken of them have touched people far beyond the world of astronomy. They hang in classrooms, museums, and bedrooms. They inspire art, music, and poetry. They remind us that beauty is not limited to Earth, that the cosmos itself is capable of breathtaking displays. When Hubble released its images of Orion, Eagle, Crab, Helix, and Carina, it was not just expanding scientific knowledge. It was expanding the human sense of awe. The cold numbers of light years and temperatures transformed into something immediate and personal. Images that feel like windows into eternity. Part of what makes these nebulae so powerful is their duality. They are both familiar and alien. The pillars of creation look like mountains, though they are made of gas. The helix looks like an eye, though it is a dying star. The Carina Nebula looks like storm clouds, though it spans dozens of light years. Our minds reach for metaphors because what we see resonates with forms we know, yet the scale and nature of these structures are utterly beyond our experience. This tension between recognition and strangeness is what makes them unforgettable. To see a famous nebula is to feel both small and connected. Small, because the structures are vast, measured in light years, shaped by forces beyond our control. Connected, because the gas glowing in those clouds contains the same elements that form our own bodies. Hydrogen, oxygen, carbon. These are the pigments of both nebulae and people. The red of Orion, the green in the ring, the blue of reflection nebulae, all of them echo in us because we are made of the same stuff. The emotional power of these images is not just their beauty, but their intimacy. They are not separate from us, they are us, seen at another stage in the cosmic cycle. As we continue to look up, with telescopes and with imagination, these nebulae remain more than patches of light. They are chapters of a universal story, written in clouds and colors, carried across thousands of years of human wonder. Orion, Eagle, Crab, Helix, Carina, they are not just names on a list. They are symbols of what it means to live in a universe that is still unfolding, still creating, still reminding us that even in the vastness of space, there is beauty waiting to be seen and felt. For as long as humans have looked up at the night sky, they have noticed not only the steady pinpoints of stars, but also the hazy patches, faint smudges that seem different, softer, less defined. To ancient eyes, these were clouds in the heavens, mysterious places that invited interpretation and wonder. The Milky Way itself, stretching as a pale river across the sky, was often described as a kind of celestial mist. In Greek mythology, it was thought to be milk spilled from the breast of Hera, the queen of the gods, while in China, It was the Silver River, separating lovers who could only meet once a year. Within that greater band, smaller smears of light, the Pleiades wrapped in faint haze, or the glow of what we now know as Andromeda, stood out as objects of fascination long before anyone understood their true nature. Without telescopes, the nebulae were enigmas, perceived as nebulous spots, too faint to resolve into stars, too distinct to be ignored. To cultures without the tools of modern astronomy, their presence carried symbolic weight. Some saw them as the breath of gods, others as the smoke of celestial fires. The word nebula itself simply means cloud in Latin, reflecting how little was known and how much was left to imagination. For many centuries, these hazy forms were grouped together with comets and meteors as strange phenomena of the upper air, their true distances and scales unguessed. What we now call nebulae were, to early observers, part of a sky that felt close, immediate, and alive with mystery. Even after telescopes entered the picture, confusion reigned. The early astronomer Charles Messier compiled a catalogue in the 18th century of fuzzy objects he wanted to avoid mistaking for comets. Among them were true nebulae, but also galaxies far beyond our own. To his eyes, they all looked similar, diffuse patches of light against the dark. For a long time, no one knew which were within our Milky Way and which were separate universes entirely. The Andromeda Galaxy, visible as a smudge to the naked eye, was called the Great Andromeda Nebula. Other spiral galaxies received similar names. The word nebula became a catch-all for anything hazy, anything unresolved. Only later would careful observation and new technology peel apart these categories and show how different they really were. The question of what these smudges represented led to one of the great turning points in astronomy, the so-called Great Debate of 1920. Two astronomers, Harlow Shapley and Heber Curtis, faced off over the nature of the spiral nebulae. Shapley argued that they were part of our own galaxy, small structures within the Milky Way's boundaries. Curtis insisted they were island universes, galaxies in their own right, lying far beyond. For a time, the matter was unsettled, but the debate highlighted just how uncertain our understanding of the cosmos had been. It was not until Edwin Hubble used the 100-inch telescope at Mount Wilson to identify individual stars in Andromeda that the truth became clear. These nebulae were not inside our galaxy at all, but galaxies themselves, vast and distant. The word nebula had to shrink in meaning, giving up its role as a label for galaxies and keeping only the clouds of gas and dust that truly belong to our Milky Way and others like it. The Great Debate was more than an academic argument. It was a threshold moment when the universe expanded in human thought, suddenly far larger than anyone had previously dared to believe. But nebulae never belonged to science alone. They have always touched something deeper, something in the realm of art, poetry, and philosophy. Their forms, half seen and shifting, lent themselves to metaphor. The Romantic poets of the 18th and 19th centuries often invoked nebulae as symbols of the unknown, of mystery just beyond reach. Percy Bysshe Shelley wrote of the clouds of heaven's dew, blending the imagery of earthly mists with the faint smudges of the night sky. Painters, too, borrowed the idea of celestial clouds, using swirling forms to suggest the boundless and the sublime. In philosophy, nebulae represented uncertainty, potential, and transformation, ideas that matched perfectly with their true astronomical role as sites of creation and destruction. Even today, when we know so much more, the images captured by telescopes carry an emotional resonance that goes beyond data. The pillars of creation became iconic not because we understand ionized hydrogen, but because their form stirs something in us, echoing mountains, cathedrals, or even hands reaching upward. The Helix Nebula, nicknamed the Eye of God, strikes us as uncanny because its shape mirrors the most intimate part of human experience, the gaze. These associations are not fanciful extras, but reflections of the way human beings relate to the cosmos. We find ourselves in its patterns, even when they are vast and impersonal. Nebulae, throughout history, have thus been both scientific puzzles and canvases for imagination. They shifted from being clouds of mystery to objects of study, from mistaken identities to clarified structures, from philosophical metaphors to precise astronomical phenomena. Yet even as we learn to measure their distances and parse their chemistry, they never lost their power to move us. Ancient cultures saw them as signs of divine presence. Early astronomers saw them as problems to be solved. Modern viewers see them as both, the science explaining their form, the wonder remaining untouched. When you look at a nebula, whether as a faint smudge in the night or in the vibrant colors of a photograph, you are participating in this long human history. You are standing in the line of those who have always looked up and tried to make sense of the clouds in the sky. You are heir to the myths, the mistakes, the debates, and the art. And you are connected to the truth that has unfolded slowly across centuries, that these clouds are not illusions but real, vast structures, shaping stars and planets, shaping even the matter that makes us who we are. Nebulae carry not only the story of the universe, but also the story of our efforts to understand it, a story still being written with every new glance into the heavens. In most images of the cosmos, dust is what hides. It lies across the sky like a veil, blotting out the light of stars and making the heavens appear incomplete. To many early astronomers, these dark patches seemed like holes in the universe, places where there was nothing at all. But darkness, in space, is rarely emptiness. More often, it is dust. Tiny grains of carbon, silicates, and ice suspended across light years, thick enough to block the light of entire star fields. To see dust is to realize that the universe does not always reveal its wonders openly. Sometimes it conceals, sometimes it shrouds, and sometimes it waits. And yet dust is not only a mask, it is also a womb. Within those veils, hidden from the glare of starlight, lie the places where new stars are born. Dust provides shade, cooling gas that would otherwise be too warm to collapse under gravity's pull. Without dust, many molecular clouds would remain just that, diffuse, scattered gas. But with dust, temperatures fall, atoms cluster together, and the long process of star formation begins. It is a paradox written across the galaxy. What looks like absence is, in truth, the condition for new presence. The very material that hides creation is the same material that makes it possible. When light encounters dust, it is not simply swallowed but scattered and absorbed. Shorter wavelengths, like blue, scatter more easily, which is why reflection nebulae glow in soft azure. Longer wavelengths, like infrared, slip through more easily, which is why astronomers turn to infrared telescopes to pierce the shadows. Dust is selective, revealing and concealing according to its own rules. The shapes we see in dark nebulae, the horsehead, the snake, the coal sack, they are not random voids but outlines of this interplay. The silhouettes of clouds thick with dust, standing in front of brighter regions behind them. To the naked eye, they look like emptiness. To a sensitive instrument, they are nurseries cradling hundreds of future stars. Dust, on the smallest scale, is made of grains, only micrometers across, but their collective effect is immense. Imagine the faint smoke from a candle, delicate and translucent on its own, yet capable of turning thick and impenetrable in great quantity. Dust in space works the same way. Individually insignificant, together they shape the very structure of galaxies. They obscure half the Milky Way from optical view. They sculpt the glowing arcs of Emission nebulae, and they determine where the next stars will rise. What might seem like a nuisance to stargazers, always dimming the light, is actually one of the most important ingredients of the cosmic cycle, and dust carries more than elements. It carries chemistry. Within its grains are carbon-based compounds, organic molecules, the precursors to life as we know it. Observations have revealed complex hydrocarbons, even simple sugars, embedded in interstellar dust. These molecules drift across light years, waiting to be folded into new solar systems. When planets form, dust is their raw material, coalescing into rock and soil, providing the carbon backbone for biology. It is no exaggeration to say that the dust in nebulae holds the seeds of life. The iron in our blood, the carbon in our cells, the oxygen we breathe, all once passed through this stage, locked in tiny grains, drifting until gravity and chemistry called them into new shapes. There is something humbling about this. We often think of dust as insignificant, as something to be swept away. And yet cosmic dust is one of the most powerful agents in the universe, responsible for both hiding and creating, for both veiling and unveiling. It shapes our view of the sky, but more importantly, it shapes the sky itself. Without it, there would be no stars, no planets, no living beings to ponder the heavens. Dust is the quiet architect, working in shadows, unnoticed, until its work is revealed in the blaze of newborn suns. If you could drift inside one of these dust clouds, you would see little. The stars would vanish behind the haze, and the light around you would dim to a murmur. It would feel like being lost in fog, with no horizon, no sense of scale. And yet, in that darkness, atoms would be gathering, forces would be aligning, the future would be forming grain by grain. To stand in such a place would be to witness silence that is not empty but full to the brim with potential. The dual nature of dust, its ability to obscure and to create, makes it one of the most poetic elements of the universe. It is both mask and midwife. It denies us sight while giving birth to new things worth seeing. It ensures that the universe never reveals everything at once, that mystery and anticipation are preserved even in an age of powerful telescopes. There will always be regions hidden, places yet to be uncovered, stories still folded within the veil. And when those stories are revealed, they will not be new to the dust. They will be what the dust has been carrying all along. So when you look up at the night sky and see a patch where stars seem to vanish, remember that you are not seeing nothing. You are seeing dust, patient and protective, hiding the process of birth. Remember, too, that the atoms in your own body once drifted as part of such a cloud, unseen and waiting. Dust has always been more than dust. It is memory. It is potential. It is the bridge between the death of old stars and the birth of new ones. In its shadows, the universe takes its next breath. At first glance, photographs of nebulae give the impression of stillness. They appear frozen in their luminous shapes, serene and unmoving across the dark canvas of space. But this is an illusion created by the vastness of their scale and the brevity of our human lives. In truth, nebulae are never still. They are seas of gas and dust in constant motion, flowing, rippling, expanding, reshaping themselves over spans of time so immense that their movement seems imperceptible to us. If we could watch them in accelerated time, centuries condensed into minutes, they would look less like paintings and more like storms, clouds billowing and colliding, waves of matter rolling through the galaxy. The motions within nebulae are powered by many forces, but none are as dramatic as the aftermath of a supernova. When a massive star dies in this cataclysm, its outer layers are blasted outward at thousands of kilometers per second. The resulting shock wave races through the interstellar medium, sweeping up surrounding gas, heating it, and pushing it into expanding shells. The Crab Nebula is a testament to this motion, its filaments still racing outward nearly 1,000 years after the explosion that created it. The delicate structures we see are not static threads, but expanding waves, unraveling into space with relentless speed. To us, The crab seems like a frozen firework, but in reality, it is still exploding, still moving, still reshaping the galaxy around it. Other nebulae are shaped by gentler, though no less powerful processes. The radiation and stellar winds from massive young stars can carve their surrounding clouds into cavities and arcs, pushing material away while compressing it in other regions. This constant pressure creates ripples and filaments, sculpting the gas into forms that look like towers, pillars, and arches. The famous pillars of creation in the Eagle Nebula are not statues, but columns being slowly eroded, their surfaces crumbling under the relentless touch of starlight. They appear permanent in photographs, but in reality, they are temporary, destined to be destroyed within a few million years. Their beauty lies in this fleeting balance between creation and destruction, captured in a single moment of their transformation. Sometimes nebulae even collide with one another. In the vast expanse of a galaxy, molecular clouds can drift into each other's paths, merging in slow, turbulent dances that last for millions of years. When they do, the chaos triggers bursts of star formation, as shock waves and compressions create pockets dense enough for gravity to take hold. What was once two separate clouds becomes one new structure, richer and more complex than before. The boundaries blur, the shapes twist, and a new nebula emerges from the encounter. These collisions remind us that even in the deep silence of space, nothing is truly isolated. Clouds influence clouds, stars influence stars, and everything is in conversation with everything else. If we could look at nebulae not in the frozen snapshots of photographs, but in the flowing continuity of their true nature, we would see living sculptures. Imagine curtains of gas billowing like smoke, pillars slowly thinning as their tops evaporate into the void, waves of matter rolling outward from unseen blasts, and tendrils curling back upon themselves under the pull of gravity. It would look less like a still picture and more like a vast, slow-motion ballet, choreography written in hydrogen and oxygen, in dust and plasma. Gravity is the sculptor, light the paintbrush, and time the stage. What we see through telescopes are frames in an endless performance, frozen so our eyes can hold them, but alive nonetheless. This constant motion is not wasted. It is motion with purpose. Expanding shells from supernovae spread heavy elements across the galaxy, enriching the raw material for future stars and planets. Winds from young stars push back surrounding clouds, creating clearings where clusters of siblings can shine freely. Collisions between clouds ignite cascades of new birth, setting off waves of formation across whole regions of the sky. Even the slow erosion of structures like the pillars of creation is part of the cycle, dispersing gas into the wider galaxy to one day gather again. The motions of nebulae are the motions of life at the largest scale, energy always flowing forward, always carrying matter from one chapter to the next. To think of them as static is to misunderstand them. Nebulae are not paintings hung in the night sky. They are weather systems on scales so vast they defy imagination. They are storms that last millions of years, waves that crash across light years, breezes made of radiation strong enough to carve entire clouds. They are slow, yes, but they are never still. The universe is always in motion, always shaping and reshaping itself, and nebulae are among its most vivid expressions of that truth. As you picture them now, let yourself imagine the hidden movement. See the crab's tendrils stretching farther with every passing second, even if the change is invisible to your eye. See the Orion Nebula's waves of gas rolling outward, sculpted by the fierce energy of the trapezium cluster. See two massive clouds drifting together in a silent collision, their boundaries folding and twisting like currents in an ocean. See the pillars of creation, not as eternal monuments, but as towers already fading, slowly dissolving into starlight. Nebulae in motion remind us that the universe is alive, not in the sense of breath or heartbeat, but in the ceaseless exchange of energy and matter. Nothing is fixed. Nothing is permanent. Every shape is temporary, every form a passing moment in a much larger rhythm. To look at a nebula is to see a sculpture frozen only for our benefit, captured mid-motion, mid-change. And to know this is to understand that the cosmos is not still, but endlessly dynamic. A river of creation flowing through the night. In the quiet folds of the cosmos, nebulae act as more than clouds of gas and dust. They are chemical factories, the great alchemists of the universe. Within their hazy reaches, elements are forged, transformed, and scattered across the stars, weaving the raw ingredients that make planets, oceans, and life itself possible. To drift through a nebula is to drift through the very workshop of existence, where atoms collide, combine, and climb the ladder of complexity that leads from simple hydrogen to the heavy metals etched into your bones. Nebulae are not passive backdrops, but engines of chemistry, shaping the universe's recipe, one element at a time. It all begins with hydrogen, the most abundant element in the universe, and the primary fuel of creation. For billions of years, vast molecular clouds of hydrogen lie waiting, diffuse and silent, until gravity draws them inward. As regions collapse, hydrogen atoms are pressed together with such force that they fuse, releasing enormous amounts of energy. This fusion is the heartbeat of a star, the quiet fire that allows it to shine. From hydrogen, helium is born, and in the burning cores of stars, the chain reaction continues. Nebulae, in this sense, are both the cradle and the supply line, reservoirs where the simplest elements are gathered before being ignited into the next steps of cosmic alchemy. But helium and hydrogen alone cannot explain the richness of the cosmos. The oxygen you breathe, the carbon in your cells, the calcium in your bones, none of these could exist without the fiery forges of stars that were once born in nebulae. Within the dense hearts of massive stars, fusion continues past helium, stacking atoms together into heavier and heavier forms. Carbon, nitrogen, oxygen, silicon, and eventually iron emerge from these processes, each step requiring more pressure and more heat, each step an advance in the cosmic symphony of chemistry. When these stars reach the end of their lives, they do not fade quietly. They return their riches to the nebulae around them, casting off layers in stellar winds, or exploding in brilliant supernovae, scattering their elements across space like seeds carried on a stellar wind. Iron is the threshold, the great stopping point of stellar alchemy. Beyond it, fusion consumes more energy than it releases, and no star can sustain it. To make elements heavier than iron, gold, platinum, uranium, the universe requires catastrophes of an even greater scale. In the wake of neutron star collisions and certain supernovae, shock waves and densities unimaginable force atoms together into these rare and precious forms. The violence of these events becomes the source of beauty, flinging the new elements outward where they settle into the gas and dust of nebulae. From there, they are incorporated into new stars, planets, and eventually into life. This is how the periodic table is written, not in a laboratory, but in the stars. Each nebula holds within it the record of countless generations of stellar lives, each one leaving behind its chemical signature. Astronomers can read these signatures in the light that travels to us, spectra split into lines that reveal the presence of oxygen, nitrogen, carbon, sulfur, and more. In these patterns, the history of the universe is preserved, written in color and flame. A star born in one region may glow with the abundance of carbon from an ancient explosion. Another may shine faintly, its light revealing only the simplest atoms of hydrogen and helium, a relic of the earliest times. Nebulae become libraries of chemistry, their contents written into the very light they emit. Consider the Orion Nebula, where newborn stars carve cavities into their parent cloud. In the glowing gases, astronomers detect bright red hydrogen, sharp green oxygen, and faint traces of sulfur. These are not just colors but clues, fingerprints of the universe's evolving recipe. In the Crab Nebula, remnants of a star that died 1,000 years ago. The filaments shimmer with iron and calcium, remnants of a supernova's violent alchemy. These filaments are not just debris, but the raw material for future worlds. Somewhere, someday, a planet may form with iron at its core and oxygen in its sky because of the ashes drifting in that cloud. Even the dust in nebulae carries the marks of chemistry. Microscopic grains form from cooled atoms of carbon, silicon, and iron, sometimes coated with water or organic molecules. These grains drift through the cloud like tiny capsules of potential. They block starlight, they scatter colors, but more importantly, they carry with them the seeds of life. Comets and asteroids in young planetary systems often inherit these compounds, delivering them to rocky worlds where chemistry can take its next steps. The nebula, then, is not only a birthplace of stars, but a potential birthplace of biology, writing not just the elements, but the first chapters of life into the cosmos. To think of nebulae as chemical factories is to recognize the deep connection between cosmic violence and cosmic creativity. The elements in your blood and bones were once locked inside stars that lived and died long before Earth formed. When you breathe, the oxygen in your lungs is ancient, born in some long-vanished stellar nursery. The iron flowing through your veins is the legacy of supernovae, violent deaths turned into the structure of life. In this way, nebulae are not distant or abstract. They are personal, written into your very body, reminders that we are participants in this ongoing cycle of creation. The story of nebulae is the story of transformation, of simple hydrogen atoms rising through stages of complexity until they build stars, planets, oceans, forests, and living beings who can wonder about their origins. Every time a nebula glows, it is telling part of that story. Its colors not just beautiful, but meaningful coded messages of chemistry unfolding across time. And though the process is vast and slow, it is constant. New stars are forming now, fusing hydrogen into helium. Old stars are collapsing, scattering their elements. Clouds are gathering, waiting for the nudge of gravity. The factory never closes. The alchemy never ends. And so, when you look at an image of a nebula, remember that you are seeing more than a cloud. You are seeing the machinery of creation, the places where the universe forges the materials of itself. You are seeing the origins of everything solid, everything living, everything known. In the quiet fog of a nebula, the periodic table is not a chart on paper. It is a living, luminous process, still at work, still writing the story of matter across the night sky. When we think of nebulae, we often imagine the colorful glowing clouds made famous by photographs from Hubble and other great telescopes. Vivid reds from hydrogen, eerie greens from oxygen, and delicate blues from scattered starlight form images so striking they look like paintings brushed across the sky. Yet what the human eye can see, even with the help of lenses, is only a fraction of the story. Most nebulae are invisible to us. They exist in forms of light beyond our sight, whispering their presence in radio waves, glowing fiercely in X-rays, or shimmering in infrared heat. To know the true nature of nebulae, we must listen with more than our eyes. Some of the largest nebulae in the galaxy are not luminous clouds of emission or reflection, but sprawling molecular giants. These are enormous reservoirs of hydrogen gas, mixed with dust, stretching for hundreds of light years, so vast they could swallow entire clusters of stars. They do not glow brightly in visible light because their atoms are cold and quiet. Instead, they emit faint signals at radio wavelengths, far longer than the red light we can see. Only radio telescopes can tune in to these signals, like giant ears pressed against the sky, listening to the slow heartbeat of molecules across the galaxy. Through this listening, astronomers have discovered that our Milky Way is threaded with hidden rivers of molecular gas, shaping where new stars will be born. The Orion molecular cloud complex, for example, is not just the bright nebula visible through telescopes, but an entire hidden system of cold, dark gas that stretches much farther, revealed only in radio maps. Within these radio images, astronomers trace carbon monoxide, ammonia, and other molecules, sketching the outlines of clouds that are invisible to ordinary vision. The scale is breathtaking, for these clouds are the wombs of future stellar generations, concealed from us except in whispers at the longest wavelengths. Infrared light reveals another side of the hidden cosmos. Dust, which blocks visible starlight, glows faintly in the infrared, radiating warmth from the energy it absorbs. Where the eye sees only darkness, an infrared telescope sees intricate detail, revealing stars being born behind thick curtains of dust. The famous Orion Nebula, dazzling in optical images, looks even richer in infrared, filled with hundreds of young stars, otherwise hidden in its depths. Entire clusters emerge from the shadows when viewed this way, as though a veil has been lifted. The James Webb Space Telescope, with its infrared vision, has become our newest lantern in these dim realms, unveiling galaxies, nebulae, and structures the universe has long kept secret. Infrared light also lets us see further into the distant past. Because the universe is expanding, the light from ancient galaxies is stretched and shifted into infrared by the time it reaches us. In a sense, looking at nebulae in the infrared is like looking backward in time, catching glimpses of star formation as it happened billions of years ago. These images show us not only how stars are forming today in nearby nebulae, but how the earliest stars once kindled in the young universe. Dust that blinds us in visible light becomes a messenger here, glowing gently with the warmth of its history. At the opposite extreme, there are nebulae so violent that they radiate not in visible or infrared light, but in X-rays, invisible to our eyes but detectable with special instruments orbiting high above Earth. These are the remnants of explosions, the shock-heated gas of supernovae glowing at millions of degrees. The Crab Nebula, already remarkable in visible light, blazes even brighter in X-rays, its pulsar core flooding the cloud with high-energy radiation. These views reveal filaments of gas being accelerated to extraordinary speeds, twisted magnetic fields, and particles pushed to energies far beyond what human technology can achieve. Where visible light shows beauty, X-rays show raw power, the aftermath of destruction that reshapes the galaxy. There are even nebulae best seen in gamma rays, the highest energy light of all. These are rare and exotic, often linked to pulsars and the most extreme remnants of stellar death. In these glimpses, nebulae become not clouds of gentle color, but fountains of violence, blasting energy across space in jets and arcs. To see them is to be reminded that the universe is not only serene but also fierce, filled with forces we can barely imagine. The truth of nebulae, then, is that they exist in every wavelength, each one revealing a different face of their identity. Visible light gives us beauty, the glowing reds and greens that inspire awe. Radio waves give us scale, mapping the hidden architecture of molecular clouds. Infrared gives us birth, unveiling stars just beginning to shine behind dusty curtains. X-rays and gamma rays give us death, showing the brilliant and violent aftermath of stellar explosions. Together, these perspectives create a complete picture, like instruments in an orchestra, each adding their part to the symphony. It is humbling to think that for most of human history, these invisible nebulae went completely unnoticed. We looked up and thought the universe was filled with emptiness, with only a few smudges breaking the pattern of stars. Now we know that the darkness itself is filled with structure, with hidden rivers and glowing embers, with light our eyes cannot see but our instruments can capture. The universe is richer than appearance, more layered than vision alone could ever reveal, and perhaps this is what makes nebulae so compelling. They remind us that reality always exceeds perception. Just as dust conceals while enabling creation, so too does light conceal its fuller spectrum, hiding truths until we invent new ways to see. The visible nebulae we admire are only the beginning, surface impressions of deeper processes that extend across wavelengths and across time. To look at them is to realize that every mystery carries hidden dimensions, waiting for the right instrument to bring them into view. So the next time you see an image of a nebula, glowing with its familiar palette of colors, imagine the invisible layers folded within it. Picture the radio signals humming beneath, mapping vast hidden clouds. Picture the warmth of dust glowing in infrared, revealing stars you cannot see. Picture the furious light of X-rays and gamma rays, invisible but blazing, telling the story of violence and rebirth. To see nebulae in this way is to see the universe as it truly island, not static or shallow, but profound, hidden, and endlessly more than meets the eye. In the depths of winter, when the night sky is sharp and clear, Orion rises in the east, carrying with him one of the richest regions of the heavens. His belt of 3 stars is instantly recognizable, a landmark for stargazers across the world. Just below that belt, a faint, glowing patch reveals itself, a blur to the naked eye, a delicate curtain through binoculars and through telescopes, one of the most breathtaking sights in the sky. This is the Orion Nebula, M42, a vast and living cloud of gas and dust, a place where stars are being born even now. For centuries, it has been a source of wonder, but today we know it as something even greater. A stellar nursery so close and so active that it has become astronomy's ultimate classroom. The Orion Nebula is only about 1,350 light-years away, close in cosmic terms, and it sprawls across a region nearly 25 light-years wide. Within its glowing folds, thousands of young stars are forming, some visible, some hidden behind curtains of dust. The light that reaches us is powered by the fierce radiation of a cluster of young stars at its heart, their brilliance igniting the surrounding hydrogen into a crimson glow. Seen through a telescope, the nebula looks alive, with wisps curling outward, dark lanes cutting through luminous arcs, and shadows that suggest movement, even though they shift on timescales too vast for us to witness directly. It is the closest place where we can see, with clarity, the very process that once gave birth to our own Sunday. At the center of the nebula lies the trapezium cluster, a group of 4 massive young stars locked in a tight gravitational embrace. Their light is intense, ultraviolet radiation pouring outward, heating and ionizing the surrounding gas. Their winds carve cavities and sculpt ridges, creating a stormy landscape where creation and erosion happen side by side. These stars are only a few million years old, mere infants compared to the 5 billion-year age of our Sunday, and their unruly energy defines the nebula's character. They are both sculptors and destroyers, shaping the clouds around them even as they strip away the material from which future stars might form. The trapezium is like the beating heart of Orion, its pulsing light radiating across the galaxy. Surrounding M42, the Orion complex stretches wider, encompassing other remarkable structures. To the south lies the Running Man Nebula, a reflection nebula that glows softly in the blue light of nearby stars. To the north, nestled near Orion's belt, lies the famous Horsehead Nebula, a dark silhouette of dust rising against a glowing background, its profile uncannily like that of a horse rearing in the night. The Horsehead is a perfect illustration of the dual nature of nebulae, at once obscuring and creating, its darkness hiding the stars within, its shape revealed only by the light it blocks. Nearby burns the Flame Nebula, its bright regions lit by ultraviolet light from the star Alnitak, the easternmost star of Orion's belt. The flame's tangled folds of dark and bright gas resemble fire leaping into the sky, an illusion created by light and shadow on a cosmic scale. Together, these structures form the Orion Molecular Cloud Complex, a region spanning hundreds of light-years, filled with gas, dust, and newborn stars. It is not only beautiful but invaluable to science. Because of its closeness, astronomers can study Orion in detail, resolving features that are blurred in more distant nebulae. Every stage of star formation can be found here, from cold molecular clouds where collapse is just beginning, to hot young stars already blazing and dispersing their cradles. It is a natural laboratory, a place where we can learn how stars are born, how they live, and how they shape their surroundings. For this reason, Orion has been called astronomy's greatest classroom, a region that teaches us about our own origins as much as about the stars themselves. The Orion complex also tells a story of time and succession. The trapezium cluster may dominate today, but it is only one generation of stars among many. Older stars already populate the region, some of them moving away, some of them having exploded long ago, seeding the complex with heavier elements. New stars are constantly igniting, adding their light to the nebula, while others remain hidden, waiting for the right moment to pierce the dust around them. Orion is not a single act of creation, but an ongoing symphony, with movements overlapping, each generation influencing the next. It is a reminder that star formation is not isolated, but part of a great continuum, stretching backward into the past and forward into the future. For observers on Earth, Orion has long held a special place. To ancient cultures, the bright stars of the hunter carried myth and meaning, but the faint glow of the nebula went unnoticed or unremarked. Only with the invention of the telescope did its true nature begin to reveal itself, and even then, it took centuries for astronomers to understand what they were seeing. Today, with instruments that can peer into every wavelength of light, we can map its hidden structures, trace its chemical composition, and even watch young stars flicker and flare as they accrete matter. And yet, for all the science, the Orion Nebula remains one of the most awe-inspiring sights in the sky. A vision that needs no explanation to stir the imagination. Standing beneath Orion on a clear night, it is possible to feel the weight of connection. The nebula is not just a distant wonder, but a reflection of what once happened here, in the cloud that gave birth to our own sun and planets. The same processes shaping Orion now shaped Earth long ago. The same dance of gravity, light, and dust that we watch in Orion's complex once played out in our own corner of the galaxy, leading eventually to forests, oceans, and human beings looking up in wonder. To see Orion is to look not only at the present, but at our own past, preserved in another place, another time. And perhaps this is why Orion resonates so deeply. It is more than a beautiful nebula. It is a reminder that creation is not a distant story, but our story, too. The glow beneath Orion's belt is a beacon across space, calling us back to where we began, and forward to where stars will continue to rise long after we are gone. When a star dies in a supernova, the universe remembers. The event is so violent, so luminous, that it can outshine an entire galaxy for weeks, casting light across the cosmos from a single point of destruction. But the brightness fades quickly, leaving behind something quieter, something enduring, the remnant. These supernova remnants are the echo of death, clouds of debris racing outward, expanding for thousands of years, carrying with them the elements forged in the star's life and final breath. They are graves and gardens at once, places where endings are written into new beginnings. The Crab Nebula is one of the most famous of these remnants, and for good reason. In the year 1054, people on Earth witnessed the death of a massive star. In China, court astronomers recorded a guest star that shone so brightly it was visible in daylight for weeks. In Japan and the Middle East, similar accounts were written, testimonies to a star's last act witnessed by those who had no way of knowing its cause. That explosion sent shockwaves into space, and nearly 1,000 years later, the debris continues to spread outward, forming the tangled filaments of the Crab Nebula. Seen today through telescopes, The crab is a web of glowing threads, delicate and chaotic at once. The filaments are made of gas hurled into space at thousands of kilometers per second, expanding ever outward, stretching into new shapes as the years pass. Each filament carries elements forged inside the star: hydrogen, helium, oxygen, sulfur, and iron, cast into the interstellar medium like seeds scattered in a field. The colors we see in images are not embellishments but signatures: red from ionized hydrogen, green from sulfur, blue from oxygen, each telling a piece of the story. To look at the crab is to see the star's very body, ripped apart and spread across space. At the center of this wreckage lies something astonishing: a pulsar, the collapsed core of the dead star. It is a neutron star, an object so dense that a teaspoon of its matter would weigh billions of tons. Spinning 30 times each second, it sends out beams of radiation like a cosmic lighthouse, sweeping across space with clockwork precision. The pulsar pumps energy into the nebula, lighting it from within, driving winds that shape the filaments and accelerate particles to near the speed of light. The crab is not just debris, it is alive with the heartbeat of its remnant, a dead star that still exerts influence over everything around it. This duality, the stillness of death and the persistence of motion, defines all supernova remnants. They are created in violence, yet they evolve in silence, expanding across thousands of years, transforming as they go. Their filaments are not random but structured, shaped by the interplay of shock waves, magnetic fields, and gravity. Over time, the expansion slows, the gases mix with the surrounding interstellar medium, and the remnant fades. But by then, its purpose has already been fulfilled, for the material it carries has been delivered into the galaxy, ready to join the next generation of stars and planets. Supernova remnants are recyclers. Every atom heavier than hydrogen and helium in your body once passed through a star, and many of them through explosions like these. The carbon in your cells, the calcium in your bones, the iron in your blood. These were forged in stellar hearts and scattered by supernovae. The debris drifting through the crab today will one day enrich other clouds, forming new suns, new planets, perhaps even new life. In this way, death is never the end. It is transformation, the handing forward of elements, the continuation of a story written in the language of matter and light. Other remnants across the galaxy echo the crab's tale. The Veil Nebula in Cygnus, a great lacework of glowing filaments, is the shattered shell of a star that died thousands of years ago. Cassiopeia A, one of the youngest known remnants in our Milky Way, still crackles with X-ray light, revealing knots of gas hurled into space at astonishing speeds. Each remnant carries its own shape, its own fingerprint of destruction, shaped by the size of the star, the nature of the explosion, and the surrounding environment. But all share the same essence: matter recycled, creation born out of catastrophe. The power of these remnants lies not only in their science but in their symbolism. They are monuments to impermanence, reminders that even the most stable-seeming stars are not eternal. Yet they are also monuments to resilience, proof that destruction can seed creation. Without supernovae, galaxies would lack the raw materials for rocky planets. Without them, life would have no carbon, no nitrogen, no oxygen. We owe our existence to the stars that died long before Earth was formed, their remnants enriching the clouds from which our solar system was born. In the Crab Nebula, we see this truth vividly. The explosion was once a moment of brilliance in the sky, bright enough to be mistaken for a second Sunday. Now, centuries later, it glows as a delicate lattice, carrying forward the remnants of a life ended long ago. And within it, the pulsar spins, a lighthouse in the fog, steady as the centuries pass, a reminder that even in endings, there is rhythm, persistence, and continuity. To watch a supernova remnant is to witness time itself stretched out into a visible form. We see the echo of an explosion long past, still expanding, still reshaping the galaxy. We see matter once locked inside a star now free to join the wider universe. We see how death in the cosmos is never empty, but always full, always leading to something else. The crab, the veil, Cassiopeia A. These are not graves but gardens, their filaments weaving the future even as they mark the past. And in their quiet expansion, we find our own reflection, for we too are remnants, built from the ashes of stars that lived, died, and gave themselves to the cosmos. Planetary nebulae are among the most hauntingly beautiful sights in the sky, and yet their very name is the product of a mistake. When astronomers in the 18th century peered through their modest telescopes, they saw glowing circles of light that resembled the disks of distant planets. They were not planets at all, of course, but shells of gas shed by dying stars, drifting outward into space like the last exhalations of a life nearing its end. The name endured, a mislabel that stuck, and so these stellar ghosts carry the title of planetary nebulae, even though their true nature has nothing to do with planets. Instead, they are monuments to endings, luminous cocoons left behind when stars like our Sun reach the close of their long journeys. The Helix Nebula is perhaps the most famous of them all, often called the Eye of God for its striking resemblance to a vast, staring gaze suspended in the dark. Located in the constellation Aquarius, it lies just 650 light-years away, close by cosmic standards, making it one of the nearest planetary nebulae to Earth. To the naked eye, it is faint, little more than a ghostly blur, but through telescopes it becomes something extraordinary, a glowing halo of expanding shells, rich in detail, with filaments and knots radiating outward. At its center lies the fading white dwarf, the ember of a star that once blazed like the Sunday. Around it, the gas it expelled glows in blues, greens, and reds, colors determined by the elements within. Oxygen, hydrogen, nitrogen, all fluorescing under the last fierce radiation of their parent. What makes planetary nebulae so striking is their symmetry. Unlike the chaotic webs of supernova remnants, these shells often form perfect circles, ovals, or even more intricate patterns. Rings, lobes, and butterfly wings. They are shaped not only by the star's winds, but by its hidden companions, unseen binary stars that can sculpt the outflow into delicate designs. The result is something that looks intentional, like a cosmic mandala or the iris of an enormous eye, etched into the sky with exquisite care. The helix, with its layered shells and wisps that extend for light years, is only one example of this artistry. Others, like the Ring Nebula in Lyra or the Cat's Eye Nebula in Draco, each display their own unique form, like signatures left by stars as they bow out of the stage. Yet for all their beauty, planetary nebulae are fleeting things. They last only a few tens of thousands of years, a blink compared to the billions of years a star spends in stable burning. Once a star like the Sun has exhausted its supply of hydrogen and helium, its core shrinks and its outer layers puff out, casting off vast envelopes of gas. The hot core, now exposed, floods the shell with ultraviolet light, making it glow. But eventually, the white dwarf cools, the radiation fades, and the shell disperses into the galaxy, absorbed back into the interstellar medium. The planetary nebula dissolves, leaving behind only the compact star remnant, dim and quiet. These brief apparitions are the swan songs of stars, luminous farewells before silence. What they tell us about our own future is sobering and strangely comforting. The Sun, steady as it seems, will one day face the same fate. In about 5 billion years, it will swell into a red giant, swallowing Mercury and Venus, perhaps even Earth. In that stage, it will shed its outer layers, sending great plumes of gas drifting outward. Its core will collapse into a white dwarf, a dense star no larger than Earth but with nearly half the Sun's mass packed inside. Around it will glow the last exhaled shells, forming a planetary nebula that may look, to distant eyes, like the Helix or the Ring. Our sun will paint its own luminous halo in the sky, a final gesture before fading into quiet obscurity. And yet, in this seeming ending lies renewal. The gas shed by stars in planetary nebulae is rich with elements, carbon, nitrogen, oxygen, that enrich the interstellar medium. These materials, mixed into new clouds, form the raw ingredients for fresh generations of stars and planets. The air we breathe, the water we drink, the tissues of our bodies, all of these contain atoms once scattered in such nebulae billions of years ago. When we look at the helix or the ring, we are seeing not only death but the cycle of life on a cosmic scale, the passing forward of material from one star's end to the beginning of countless others. There is a quiet dignity in planetary nebulae, a grace to their endings, unlike supernovae, which blaze in violence. Planetary nebulae slip into their afterlife with calm brilliance, their shells expanding silently into the night. Their symmetry and form make them feel almost peaceful, as though the universe itself is honoring the long labor of the stars that created them. The Helix Nebula's great eye seems not only to look outward but inward as well, a mirror held up to remind us of our origins and our eventual return to the stars. To study them is to confront impermanence, but also continuity. They remind us that everything changes, that endings are unavoidable, but that from those endings comes the possibility of something new. The shells of dying stars become the breath of galaxies, scattered wide until they gather again. Our sun will one day contribute its own material to this cycle, adding its atoms to the tapestry, joining the endless exchange that defines the universe. And just as we are made from the remnants of stars long gone, so too will the future be made from the remnants of us. In the delicate shapes of planetary nebulae, the cosmos whispers of time, transformation, and return. They are eyes in the sky, gazing at us across light years, reminding us that all stars, even our own, are destined to give their last light to the darkness, and in so doing, keep the universe alive. There are places in the night sky where the stars seem to vanish, as though someone has spilled ink across the canvas of the heavens. At first glance, these patches look like voids, regions of nothingness, interrupting the glitter of the Milky Way. But the darkness is not emptiness. It is substance, thick and concealed, clouds of dust and gas so dense that they block the light behind them. These are dark nebulae, shadows in the sky, hiding as much as they reveal, and within their depths, something extraordinary is taking place. One of the most famous of these is the coal sack, a vast blot of darkness in the southern sky. Nestled near the Southern Cross, it has been recognized for centuries, a stark absence that contrasts with the star-rich fields around it. To the naked eye, the coal sack looks like a hollow carved into the Milky Way, but in truth it is a massive cloud of dust and gas, hundreds of light years across, blocking the stars beyond. For indigenous cultures of the southern hemisphere, the coal sack was not a void but a presence, woven into constellations and stories. Its darkness was not the absence of light, but the presence of mystery. Barnard 68 is another such shadow, smaller and more intimate, lying only 500 light-years away in the constellation Ophiuchus. To look at it through a telescope is to see a perfect black oval, utterly devoid of stars, so stark that it seems as if someone has punched a hole through the sky. Yet this impression is an illusion. Barnard 68 is no void, but a dense, cold cloud, its dust blocking nearly all visible light. What makes it remarkable is not only its darkness, but what lies within it. Astronomers believe it is on the verge of collapse, a star about to be born. In a few 100,000 years, Barnard 68 may no longer be a dark blot, but a bright young star, shining where once there was shadow. Then there is the Snake Nebula, a twisting, sinuous structure in the constellation Ophiuchus, stretching across the sky like a dark ribbon. Its shape is unmistakable, a long coil winding through the star field, obscuring everything behind it. To the eye it looks inert, but inside it is alive with activity. Embedded within the dark coils are small knots of dense gas, places where gravity is tugging material inward, forming stellar embryos. These hidden nurseries are invisible to us in visible light, but infrared observations reveal them, glowing faintly with the warmth of their collapse. The Snake Nebula is both shadow and seedbed, a striking example of how darkness conceals creation. Dark nebulae remind us that the universe does not always speak in light. Sometimes it whispers in silence, in the absence of glow, in the places where stars seem to disappear. They challenge our instinct to equate brightness with importance, teaching us that what is unseen can be just as vital, if not more so. Within their cold, opaque interiors, molecules form and persist. Hydrogen pairs with hydrogen, carbon with oxygen. Long chains of organic compounds begin to emerge. These are the hidden laboratories of the cosmos, places where chemistry unfolds quietly, shielded from the harsh radiation of nearby stars. Without such protection, the fragile steps toward complexity could not occur. The paradox of dark nebulae is that their very darkness is what makes them fertile. By blocking starlight, they allow their interiors to cool, creating the conditions necessary for collapse. The colder the gas, the easier it is for gravity to overcome its pressure, pulling atoms together into denser and denser knots. Eventually, these knots ignite, becoming stars. In this way, dark nebulae are both veils and wombs, hiding their treasures until the moment comes when they can reveal them. To study them, astronomers must look not with ordinary eyes but with instruments tuned to longer wavelengths. Infrared light can slip through the dust, unveiling clusters of newborn stars where once there seemed to be none. Radio telescopes can trace molecules within the clouds, mapping their structure and motions. What appears to us as blackness becomes, under the right vision, a landscape rich with detail, filaments, cores, and seeds of suns yet to come. Barnard 68, the coal sack, the snake. All of these shadows hold futures inside them, hidden until we learn how to see. There is a kind of poetry in this. Darkness, so often feared or misunderstood, becomes a cradle of light. The stars that illuminate the night sky, the stars that guide and inspire us, were once hidden within such shadows. Our own sun was likely born in a dark nebula long ago, its first flickers shielded from the gaze of the galaxy. The atoms in our bodies, the carbon, the oxygen, passed through these hidden places, gathering in silence before joining the wider world. Darkness, then, is not the end of the story, but the beginning. Standing beneath the Milky Way, it is easy to be captivated by the stars, by the brilliance of Orion, or the sweep of Sagittarius. But to notice the shadows, the silent gaps where stars vanish, is to deepen that wonder. For those gaps are not absence but presence, not nothingness but abundance, waiting to be transformed. The coal sack is not an empty scar, but a vast storehouse. Barnard 68 is not a hole, but a cocoon. The Snake Nebula is not a void, but a river winding with possibility. Dark nebula remind us that not all truths shine. Some truths must be sought in shadow, in silence, in patience. The universe balances light with darkness, brightness with obscurity, and both are necessary for creation. The stars we admire are only one half of the story. The other half begins in the hidden places, where the sky looks empty but is, in fact, full beyond imagining. And in that darkness, the future glows, unseen, waiting to be born. Giant molecular clouds are the true titans of the galaxy, vast and sprawling structures that stretch for hundreds of light years. their bulk dwarfing even the grandest of the nebulae we usually imagine when we think of the night sky. They are dark to our eyes, invisible in the familiar spectrum of starlight, but their presence is undeniable. These clouds are the wombs of the Milky Way, reservoirs of gas and dust so immense that the birth of new stars within them is not merely a possibility, but an inevitability. They are not isolated features, but the great scaffolding of galactic architecture, shaping where clusters of stars will appear, how spiral arms will glow, and even how galaxies themselves evolve. Inside these clouds, the air is impossibly thin compared to Earth, but dense by the standards of space. Temperatures hover only a few dozen degrees above absolute zero, so cold that atoms move sluggishly, sticking together, forming molecules like hydrogen, carbon monoxide, and ammonia. It is this chill that allows the clouds to collapse under their own gravity, giving rise to stars. Within their depths, light cannot easily escape. The dust swallows it, leaving the interiors cloaked in shadow. To us, they look like voids, but they are not voids at all. They are brimming with potential. Every cubic light-year, a reservoir of material waiting for the right nudge to ignite. Consider the Orion molecular cloud complex, one of the most studied of these giants. It stretches across the familiar constellation of Orion, encompassing the bright Orion Nebula, the Horsehead, the Flame, and countless other features. What we see with our eyes is only the brightest skin of this immense structure. Behind it lies a hidden world of dense cores and filaments, threads of matter winding across space like rivers feeding an ocean. Radio telescopes map this world, revealing shapes that no optical image can capture. Loops, arches, and vast stretches of cold molecular gas extending far beyond the glowing nebulae we admire in photographs. Orion is only one such cloud, but it exemplifies what these giants are. Cradles of entire generations of stars, bound together by gravity, shaped by time. Inside these clouds, star formation is not a rare event, but a constant, unfolding drama. The sheer volume ensures it. With millions of solar masses of gas and dust, the likelihood that some regions will collapse into stars approaches certainty. Collisions between filaments, turbulence stirred by nearby supernovae, or simple gravitational instability are enough to trigger collapse. Once it begins, the process accelerates, pockets of gas pulling tighter, heating as they fall inward, until fusion flickers and a new star shines. In Orion alone, hundreds of such births have been observed, and thousands more are likely hidden, wrapped too tightly in dust to be revealed. The scale of giant molecular clouds defies ordinary imagination. The Taurus molecular cloud, for instance, sprawls over 30 light-years, while others stretch to 100, 200, or even 500 light-years across. The Carina molecular cloud complex contains enough gas to form tens of thousands of stars, including some of the most massive and short-lived known to science. Within these giants, entire star clusters emerge, siblings born together, bound for a time before scattering across the galaxy. Each generation reshapes the cloud, their winds carving bubbles and their deaths enriching the gas with heavier elements. In this way, the giant clouds are both mothers and children, formed by earlier events and giving rise to new ones in a continuous cycle. What makes these clouds even more remarkable is their impermanence. Though they span centuries of light across and carry millions of solar masses, they do not last forever. The very stars they create also destroy them. Ultraviolet radiation from newborn giants ionizes and disperses the surrounding gas. Stellar winds blow cavities into their bulk, hollowing them from the inside. Supernovae explode within them, scattering the remains and stirring turbulence. Over tens of millions of years, a giant molecular cloud can be completely dissipated, its material dispersed into the galaxy, only to gather again elsewhere under gravity's hand. They are vast and ancient-seeming, yet transient, chapters in the life of a galaxy always moving on to new arrangements. Within their hidden interiors, molecules also play out dramas that will echo into the future. Astronomers have found complex organic compounds in these clouds, simple sugars and amino acid precursors forming on the surfaces of dust grains. These molecules survive the collapse into stars, often ending up in the disks of gas that surround young suns. From those disks, planets form, and from planets, perhaps, the next steps of life. This means that giant molecular clouds are not only the birthplaces of stars, but the earliest seedbeds of biology, scattering chemistry across the galaxy long before it finds expression in living cells. To observe these clouds requires patience and tools beyond human senses. Infrared and radio telescopes reveal them, mapping their skeletons of dust and gas, tracing the invisible into form. In these maps, the hidden universe emerges, vast filaments winding like threads of silk, knots glowing faintly with the heat of collapse, voids carved by stellar winds. It is a vision of the galaxy as alive and turbulent, less like a serene painting and more like an ever-changing weather system on a scale beyond comprehension. And yet, for all their vastness, the essence of giant molecular clouds is intimate. The atoms drifting in them are the same atoms that drift within us. The carbon in our breath, the oxygen in our blood, the iron in our cells, all of it once passed through clouds like these. The sun itself was born in such a place, billions of years ago, in a cluster that has long since scattered. We are children of molecular clouds, products of their dark potential, shaped by their collapse and dispersal. Every time we look at one, we are looking into the nursery where our own story began. To understand giant molecular clouds is to understand that the galaxy is not static, not finished. It is still forming, still birthing stars, still writing new pages into its history. The darkness of these clouds is not emptiness but fullness, not absence but potential, not silence but the quiet before song. They are reminders that creation is not a past event, but an ongoing one, unfolding even now in the cold, hidden corners of the universe. Within them, new stars already stir, faint flickers rising into being, their light not yet free to escape. And when it does, the galaxy will be brighter, richer, alive with the legacy of giants who worked unseen, shaping the future from the shadows. When we look at nebulae, it is tempting to think of them as local wonders, features of our own galaxy alone. After all, most of the famous ones, the Orion Nebula, the Crab, the Helix, reside here within the Milky Way, scattered across the spiral arms that we call home. But nebulae are not unique to our galaxy. They are a universal phenomenon, born from the same cycles of gravity, chemistry, and light that govern the cosmos everywhere. Across the universe, in galaxies near and distant, nebulae bloom like luminous signatures, marking where stars are born and where stars have died. They are the punctuation in the sentences of galaxies, bright commas, and fading ellipses written into the dark. One of the most extraordinary examples lies just outside our galaxy, in the Large Magellanic Cloud, a small companion galaxy that orbits the Milky Way. There, sprawling across nearly 1,000 light-years, is the Tarantula Nebula. Its name is fitting, for through telescopes it unfurls like a vast web of filaments, twisted and knotted, surrounding a dense core of star formation. It is the largest star-forming region known in our galactic neighborhood, so immense that if it were as close as the Orion Nebula, it would dominate the night sky, brighter than the full moon. In its heart lies a cluster of some of the most massive stars ever recorded, giants burning so hot and bright that they shape the nebula with their winds and ultraviolet radiation. The tarantula is not a quiet nursery, but a roaring forge, a storm of creation that will leave its mark on the Large Magellanic Cloud for millions of years to come. What makes the Tarantula Nebula especially significant is that it gives us a glimpse of what may have once been more common in the early universe. Massive star-forming complexes like this are rare in our Milky Way today, but galaxies in their youth may have been filled with them, blazing furnaces of gas and dust where stars formed in great clusters. The tarantula allows astronomers to study such environments close up, to see how stars interact, how they sculpt their surroundings, and how their eventual deaths in supernovae recycle material back into the galaxy. It is both a laboratory and a time capsule, a chance to witness processes that shaped not only the Milky Way, but galaxies everywhere. Nebulae beyond our own galaxy also serve as tools. Because they are bright and distinctive, astronomers can use them to measure distance. Planetary nebulae, for instance, have a fairly uniform brightness when measured in certain wavelengths, making them useful as standard candles, markers that help gauge how far away a galaxy lies. Emission nebulae, lit by the ultraviolet light of young stars, carry within their glow the fingerprints of the elements they contain. By studying their spectra, astronomers can determine the chemical composition of distant galaxies, learning how much oxygen, nitrogen, and carbon they hold. In this way, nebulae are not just beautiful, but practical. Beacons that carry information across millions of light years, allowing us to piece together the story of the cosmos. There is a strange comfort in discovering that the same patterns repeat across the universe, whether in the Milky Way, the Large Magellanic Cloud, or galaxies billions of light years away. Nebulae emerge from the same cycles of birth and death. A star collapses, a supernova explodes, a cloud gathers, a new star ignites. The details vary, the shapes differ, but the rhythm remains. The tarantula, though alien in scale, is following the same script as Orion. A planetary nebula in Andromeda is performing the same quiet farewell as one in our own backyard. Everywhere we look, the language of nebulae is written in the same grammar of matter and light, a universal story unfolding in countless variations. This repetition tells us something profound, that the universe is not fragmented, not a collection of unrelated parts, but a single, connected system bound by the same rules. The nebulae we see are not isolated spectacles, but threads in a larger tapestry, woven into every galaxy, every cluster, every corner of space. They tell us that creation and destruction are not limited to here or there, but are everywhere, shaping the cosmos in a dance that has no end. The same laws that govern the faint planetary nebula around a dying star also govern the colossal fireworks of the tarantula. The same processes that gave rise to our sun are at work in galaxies we will never visit. And in that realization comes perspective. We are not outside observers looking in on something foreign, but participants in the same story. The atoms that form our bodies once drifted in a nebula in the Milky Way. In another galaxy, other atoms are drifting in other clouds, waiting for their moment to collapse into stars, to form planets, to one day perhaps assemble into life. The cycle we belong to is mirrored everywhere, replicated endlessly, a universal pattern that binds us to the farthest reaches of the cosmos. The Tarantula Nebula, with its storm of massive stars and raging winds, is a reminder of the extremes this cycle can reach. It shows us creation in its most energetic form, violent yet fertile, destructive yet necessary. And yet it also humbles us, because it reveals that our galaxy is not unique. The beauty of Orion, the poignancy of the crab, the intimacy of the Helix, these are not singular treasures but echoes of something larger, repeated across the sky in forms we may never fully see. Every galaxy has its own Orion, its own crab, its own Helix, shaped differently but telling the same truth. When we look outward, beyond our galaxy, at the nebulae scattered across the universe, we are looking not only at distance, but at time. The light from these nebulae has traveled millions or billions of years to reach us. In them, we see the past preserved, a record of how galaxies once formed stars, how they lived and died, how they passed their elements forward. To witness a nebula in another galaxy is to glimpse both a mirror and a memory. A mirror of the processes that shaped us, and a memory of the universe in its youth. In the end, nebulae across the universe remind us that creation and dissolution are not local quirks, but fundamental truths. They are the universe at work, endlessly building, endlessly unmaking, endlessly beginning again. Whether we see them in our own Milky Way or in galaxies so far away their light began its journey before Earth even formed, they speak the same language, a chorus sung in unison across the cosmos. To drift among them, even in imagination, is to feel the vastness of connection. To know that the story written in our stars is also written everywhere, from the tarantula's blaze to the faintest nebulae on the edge of sight. When we speak of nebulae, we often think of them as the luminous art of the cosmos, colorful clouds, cradles of stars, remnants of stellar death. Yet, hidden within them lies another story, quieter and perhaps even more profound. Nebulae are not only sculptors of stars and planets, they are also laboratories of chemistry, places where the very building blocks of life are assembled. In their cold, dark recesses, on grains of dust drifting between stars, molecules form that hint at the possibility of life far beyond our world. To look at a nebula is not only to witness the cycles of stars, but to trace the origins of ourselves. For decades, astronomers have pointed their instruments at these clouds, listening not with eyes but with radio receivers that capture the faint signatures of molecules. And again, they have found them. Hydrogen, of course, is everywhere, but alongside it come more complex companions: carbon monoxide, formaldehyde, methanol, ethanol, acetic acid, even glycine, the simplest amino acid. These molecules gather on the icy mantles of dust grains, stitched together in the deep cold where temperatures hover just above absolute zero. Ultraviolet light from nearby stars or the faint collisions of particles provide enough energy to spark reactions, and slowly, over thousands of years, chemistry unfolds in silence. What emerges are organic compounds, precursors to life, floating free in the space between suns. The significance of this cannot be overstated. These compounds are fragile, and yet the universe manufactures them in abundance, seeding them into clouds where new stars and planets are born. When a star ignites, the disks of gas and dust around it inherit this chemistry. Comets and asteroids form with these molecules locked inside, preserving them for eons. And when those icy bodies crash into young planets, they deliver their cargo. On Earth, such impacts were common in the planet's early history, bombarding the surface with water, carbon compounds, and amino acid precursors. It is possible that the spark of life here began, at least in part, with material that drifted through a nebula long before the Earth itself existed. This idea is not science fiction, but grounded in observation. Meteorites that have fallen to Earth often contain amino acids, sugars, and organic molecules, suggesting that the chemistry that unfolds in nebulae does not end there. It is carried forward, locked into stone and ice, transported across light years, and deposited onto worlds like ours. In that sense, life may be less a miracle confined to Earth and more a natural consequence of the universe's processes, seated wherever the cycle of stars and nebulae repeats. Every nebula, then, is not only a star nursery but a chemical seedbed, scattering the ingredients of life throughout the galaxy. Speculation naturally arises from this. If nebulae produce these compounds everywhere, and if planets routinely inherit them, then perhaps life is not unique, but widespread. Perhaps it emerges wherever the right conditions exist, nurtured by the same molecules that drift in the Orion molecular cloud or the Taurus dark nebula. Perhaps nebulae are not just the backdrop of life, but its origin, the universal womb from which living worlds are born. Even if intelligence or complexity is rare, the spark, the first step, may be a common thread, woven into the fabric of the cosmos by the chemistry of these clouds. And yet, even without speculation, the poetry of it remains. To say we are stardust is true. The atoms in our bodies were forged in stars. But to say we are nebula-born may be even truer. For the carbon in our cells, the nitrogen in our DNA, the water that makes up most of us, all of it once drifted in clouds, condensed onto dust grains, and mingled in the dark. We are, quite literally, children of nebulae, our existence written in the chemistry that began long before Earth took shape. When we gaze at images of the Orion Nebula or the Carina Nebula, we are looking not just at beautiful structures of gas, but at the ancient workshops where the story of life itself may have begun. This connection transforms the way we view the sky. The colorful photographs are not distant spectacles but mirrors, showing us where we came from. The glowing hydrogen that paints the red arcs of an Emission nebula, the scattering dust that reflects starlight into blue. These are the same materials that, once rearranged, became the air in our lungs and the blood in our veins. To watch a nebula is to watch our own ancestry stretched out across light years, luminous and patient, waiting for gravity and time to do their work. It also reframes the silence of space. The universe often feels empty, vast, and indifferent. But nebulae remind us that within that emptiness lies possibility. Molecules gather, chemistry unfolds, and futures are seeded long before they are realized. The darkness of a molecular cloud is not sterile but fertile, a place where dust grains are coated with complexity, where the groundwork for biology is quietly being laid. Even if life never takes hold on most worlds, the potential is there, scattered across billions of light years, ready for the right circumstances. To imagine ourselves as nebula-born is to feel both small and immense. Small, because our origins lie in processes so vast that they dwarf us completely. Immense, because those same processes link us to the stars, to the galaxies, to the universe itself. We are not apart from the cosmos, but continuous with it, expressions of the same matter and chemistry that animate every corner of space. In that light, our existence feels less improbable and more inevitable, the natural flowering of nebulae, given time. So when you see the delicate filaments of the crab, or the glowing heart of Orion, or the swirling arms of the tarantula, you are not just seeing distant wonders. You are seeing the ancestors of your own atoms, the places where the molecules of life were first assembled, carried forward through stars, comets, and time, until they gathered here on Earth. The story of nebulae is the story of life, not just in metaphor but in fact. And in that story lies the profound truth that we are not simply in the universe, we are of it, made by its clouds, sustained by its cycles, destined to return to its embrace when our brief moment ends. The universe, as alive and restless as it seems, is already beginning to slow. When we look at nebulae now, at Orion blazing with newborn stars, at the tarantula roaring with its storm of giants, we are witnessing a stage of cosmic history still flush with creation. But it has not always been so, and it will not always remain this way. Star formation across the universe has already passed its peak. Billions of years ago, galaxies burned with furious productivity, their molecular clouds collapsing in torrents, birthing stars at a pace far greater than we see today. Since then, the rhythm has softened. The raw material is still there, gas and dust swirling through spiral arms, but less of it remains compared to the early universe. Slowly, inevitably, the great furnaces of nebulae are winding down. This gradual dimming changes how we must think about the future of nebulae. Today they are engines, factories where matter becomes light. Tomorrow, on cosmic timescales, they will be relics. In the next several billion years, galaxies will still create stars, but fewer and fewer. each generation depleting the supply of cold gas. Gravity will continue to collapse clouds, but with less material to draw on, the nurseries will shrink in both scale and frequency. Massive clouds like Orion or Carina, bustling with star clusters, will become rarer. Instead, smaller and more scattered nebulae will carry the work forward, less dramatic but still part of the cycle. The spectacle we now enjoy, the great glowing lanterns in spiral arms, will one day be less common, dimmed by the slow thinning of interstellar reserves. Farther ahead, trillions of years from now, the story grows stranger. Star formation will not only slow, it will nearly stop. The cold molecular clouds that make nebulae possible will be consumed or dispersed, their gases locked into long-lived red dwarfs that burn for unimaginable lengths of time. Nebulae, as we know them. Vivid birthplaces, bright farewells, will fade into history. The great emission clouds, with their reds and greens painted across the galaxy, will no longer shine. Planetary nebulae will still flicker briefly as small stars die, but even those will grow rare. The galaxy will become quieter, less restless, more a museum of stars already made than a nursery of stars yet to come. The idea of a universe without nebulae is difficult to hold, because so much of what we see today depends on them. The colors captured by telescopes, the drama of supernova remnants, the elegance of planetary shells, all of these belong to an era that will end. In the distant future, when observers look out from some surviving planet around a dim red dwarf, their night skies may seem oddly still. Galaxies will remain, stars will still twinkle, but the glowing clouds that once defined the cycles of creation will be absent. Nebulae will be remembered not as engines, but as relics of a more vibrant time. And yet, there is no reason to mourn this fading, because it is part of the same cycle that nebulae themselves embody. They are born, they shine, they dissipate, and their elements move on to new forms. The universe as a whole follows this rhythm. Its early days were fertile and chaotic, bursting with newborn stars. Its middle age, where we now live, is quieter but still rich with creation. Its far future will be calmer still, with creation nearly complete, and nebulae existing only as echoes in memory and record. This is not loss but transformation, the same pattern on a larger stage. Even as nebulae disappear, their legacy will persist. The stars they birthed will continue to shine, their planets will continue to orbit, and their chemistry will continue to ripple outward. The atoms forged in their clouds will not vanish. They will remain, locked into whatever forms the future allows. Perhaps life, scattered across the galaxy, will endure as well, carrying within it the memory of the nebulae that made it possible. In that sense, the future of nebulae is already written into us. Their role as engines may end, but their influence is eternal, preserved in every star, every world, every breath of air. To imagine the last nebula glowing in the universe is to imagine a quiet kind of grandeur. Somewhere, trillions of years from now, a small dying sun may cast off its shells, briefly illuminating the dark with one final planetary nebula. It will not be bright enough to change the destiny of the cosmos, but it will be a symbol, a last echo of the long era when nebulae ruled as creators and destroyers alike. The universe will not pause for it. The galaxies will continue their slow drift into silence. But for a moment, that lonely cloud will shine, and then fade, and then be gone. And still, that end is part of the same truth we see today when we look at Orion or the Helix. Nebulae are transient, always have been, always will be. Their beauty lies in their impermanence, in the way they embody transition between star and dust, between life and death, between past and future. Their future is to vanish, just as stars and galaxies will one day vanish, just as everything does. But in their vanishing, they leave behind all that matters, stars, planets, and the possibility of life. The universe does not need them to last forever. It only needs them long enough to pass the torch forward. So when we marvel at the great glowing clouds scattered across our skies, we are looking not only at the present but at a fleeting chapter in the story of the cosmos. Nebulae are engines today, relics tomorrow, and always, in every age, reminders that the universe is alive in cycles too vast for us to fully grasp. Their future is our future, written in the fading of light, and in the quiet persistence of matter carried onward into whatever comes next. We have wandered far together, drifting softly through 100 facts woven into the fabric of the cosmos. What began as a gentle step into the haze of interstellar clouds has stretched into a long and luminous journey, across nurseries and graveyards, over filaments of dust and rivers of light, through the bright eyes of planetary shells, and the dark silence of molecular giants. We have lingered in Orion's embrace, traced the threads of the crab's explosion, followed the coils of the snake, and rested under the gaze of the Helix. Each nebula, a lantern illuminating not only the sky, but the quiet corridors of thought. These were not just facts, but whispers, carried gently, as if the universe itself leaned close to tell its stories in the stillness of the night. What nebulae have taught us most is that endings and beginnings are not separate, but the same act seen from different sides. The death of a star becomes the soil of a new one. The scattering of dust becomes the gathering of planets. The silence of a dark cloud conceals the stirrings of suns that have not yet shone. A nebula is not a fixed thing. It is always in motion, always becoming, never quite finished. In its glow, or its shadow, lies a reminder that the universe does not hold still, that it is never content with permanence, and that every farewell is also an invitation to something yet to be born. As we have followed their shapes, their colors, their chemistry, and their legacies, we have found that nebulae are not distant curiosities, but mirrors. The same atoms that drift in those clouds drift within us. The same processes that ignite stars once gave us our Sunday. The same dust that veils the Milky Way once clothed the molecules that would become water and carbon and breath. To think of nebulae is to think of ancestry, not of something out there, but of the quiet truth that we are bound to them. We are not watching strangers. We are remembering home. In this way, nebulae are symbols not just of the cosmos, but of our own lives. We too are cycles of beginnings and endings. We inhale and exhale, we grow and wither, we give and we receive. The atoms that make us were gathered from stars that died long before Earth was born, and one day they will be scattered again, to drift, to wait, to be called into another form. To know this is not to feel small, but to feel infinite, a participant in the endless weaving of matter and light. We are not separate from the nebulae. We are their continuation. Now, as the drift slows and the night folds around us, the journey gently settles. The nebulae remain, stretched across the galaxy like glowing embers scattered on velvet. Some are still forging stars. Some are fading into silence. Some are hidden, waiting for the right light to reveal them, and all of them, in their quiet, remind us that the universe is vast and alive, endlessly patient, endlessly creative. You carry their story with you, not only as memory but as substance, for in a very real way, you are made of the same fog and fire. So, let this closing drift be a soft reassurance. You belong to this cycle. You are part of the glow and the shadow, part of the silence and the storm. Whatever changes unfold in your life, whatever endings and beginnings arrive, they echo the same rhythm written in the stars. The cosmos has been through it all before, and it will carry you gently through it too. And now, as your eyes grow heavy and the last of the words begin to blur, let the nebulae recede into the distance. Let Orion's nursery dim to a gentle glow. Let the crab's filaments stretch thin across the dark. Let the helix close its quiet eye. The stars remain above, patient and steady, waiting for you whenever you return. Drift now, softly, into sleep, carrying the light of 100 nebulae like lanterns to guide you into your own quiet night.